vibes that I have right now is like crazy.
Nice.
Crystal, I think I should just rate them or just like roast
Great. I heard great too.
I love the
I was like, she said that so casually.
It's a commercial.
Rates with a T.
No, I heard the P.
Oh, out of 10.
You
Oh,
dirty
this is
dog.
gonna be so hard. It's easy.
Well, I don't know what to do.
Oh, too
Give it
late.
back.
Good job.
I'm rating everybody's ISOs. Like I'm cooking. I get a whole page.
1 for 2. 50%. Pretty much the same thing, minus the skin.
Not that long. Probably that.
I'm afraid, Maricel, to play on that video. I'm afraid to press play on that video.
Do it. What? I don't think I'm gonna have it right here.
I'm getting Will's sister.
What?
Okay, you guys,
Cherry.
are you ready?
Oh.
No, there's not one.
Oh wait.
Can I look
You
for
got
that
cherry
when
too?
I open?
In my mouth.
Oh, I have her in my bag.
Wait, no.
Oh.
I have her in my basement.
It's right here.
So like what?
That was a bit. I don't want to chuck it at you. I can't get the edit.
Okay, you guys ready?
Wait.
Yep, we were born ready.
I gotta get a cherry.
I don't know about Nate.
I get no.
Who's gonna get cherry?
Cherries are just
What?
Yeah, that's what we did last time.
Cherry. Oh, you got cherry.
This one?
Yeah.
I mean, Will. That's all we did.
Cherries
Yeah.
are hot
This
as
should be the lasting bowl run.
Pretty easy day. This day should be pretty easy too.
Pretty easy, Dave.
For me, this should be the flying duck.
I was calculating it's gonna be easy, hard.
Here's some.
Wait, comp shop?
Easy.
Good.
Today,
Today,
good. I like
just because it's easy, today has been like the best day of the year so far. Best day of senior year.
You need a what?
Okay.
Just there's a long power strip in the front of the room.
Wait, this one?
I've been here.
Am I gonna have to sit over there?
No, it's long. You can pull it to you.
Oh, I can.
It's 30 foot long.
Wait, what around it?
Right.
That's very specific.
Esports. Esports tournament.
Yeah.
Cafeteria.
Yeah, we had one of those and then no
Wait, you
more.
want it? Brawl.
Well,
What's the
Brawl.
lesson called?
The normal distribution practice.
Ethan.
Sid probably played it for a couple years before you even.
what?
Wrong.
I hate that game.
Sid's too good.
I hate it too. I feel like it did.
It was so fun. You're good.
Are we ready?
No, Mark good. It sucks.
All right, so we're gonna go over this new thing.
Are we?
Yes. No, it's on the classroom.
Does anyone, you have that from which treasure for that?
Yeah.
Let's go.
This is the same one.
Mm-hmm.
It works. It fits. You have game in it.
Yeah, ramp.
Now my 30-foot long extension cord.
There's 45 millimeter camera.
45 millimeter cable.
Yeah.
All right, who can do number one?
Great again.
I'm trying to open it up. Oh.
I don't really know what's going on right now.
You can check it out on the classroom.
What's the name? What's the name of this?
A normal
It's like
distribution.
point, it's low.
What's that?
Brady.
Oh my course.
It's like 0.00.
Is it the same?
Why do you think it's the same?
Because they're the same.
Perfect. Yes.
Is that right?
Let's go. You know, it's too easy. Well,
It's the same.
what is it? Is it like?
It's called,
Trying to find.
the word you're thinking of, Nate, is symmetry.
Yeah, what he said.
It is a symmetrical distribution.
Wrong one.
So if you're as far from the mean on one side, that little red tail is just as far from the mean of 159 as this one.
It was the same.
So these two tails have the same area under the curve.
They're the same.
Yeah.
That's the
It's actually
Is that okay?
Yeah, whatever.
You good?
No, like, all of them.
The answer actually goes in the problem.
You stop.
0.009 something.
If you were
Actually, there is something I should mention. I don't think I've told you yet. So this is the normal distribution, also called a Gaussian distribution, also called the bell curve. You'll see I've enclosed 3 regions. So like here would be the mean, let's say, it's in the middle, the peak. And if you go 1 standard deviation to the right and 1 standard deviation to the left, you create, that's, if you know, within 1 standard deviation of the mean, either way, there are 68%, nearly 70%, about 68% of the area of the curve is in that range. So that's 68% of the area. Does that make any sense?
Yeah.
So if this distribution represented values falling within a certain range, 68% of all the values would be between this edge and this edge. If you went 2 standard deviations away within that range, there are 95% of all the values between these 2 marks. And if you go 3 standard deviations, it's like 99.7% of all the values are in this range. That's referred to as the empirical rule. And so, you know, if there's, it's 68, 95, 99.7. That's just a little rule for if you're within 1, 2, or 3 standard deviations. That's why beyond 3 standard deviations, there's almost no values that fall outside of that range. All right, so yeah, again, this number 100 was 59 to the left of the mean, and 218 should be 59 to the right of the mean. So these 2 tails are the same size, and so the probability should be the same. Is that okay? Number 2.
Ooh.
Spooky. What do you think? Yeah, that's the same thing again. Yeah. So
Oh,
I told you this one was gonna be an easy one.
too easy out here.
How about this one?
Oh, that's a little tight.
Number 3?
Yes, number 3.
The 0.9.
It is 0.9. Yes.
0.9.
Is that low?
Will.
Does that make sense?
Yeah.
It's the opposite of 0.1.
I was seeing that.
Yeah, there's 1 underneath the whole curve. If there's 0.1 to one side of it, that must be 0.9 to the other side.
Oh, yeah, that's a chicken.
Is that okay? You guys good?
Keep doing it, though.
Number 4. It's a tricky one. You have to put on your thinking
Would it
caps.
be like the top, like
Oh,
would it be
we got this. This is
the
doable.
top point right there? Let me look back.
Yes. What were you asking?
It'd be the like top,
I know what to do.
Oh, do
like where the peak.
Say it, man.
The peak?
Yeah, would it be like right up at the top?
The peak is at
Yeah.
250.
People.
No, like other. It says between 200 and 300. To the
Point 524.
This, yeah, they want,
You're right, Nate.
That's another chicken.
what'd you get?
0.52.
552? How'd you get it?
1 minus 0.762. And we got 0.238, and then 0.762 minus 0.238. You got another part.
That's not right.
Well, it's the 200 is 300.
Yeah, that would work, yeah.
That might be the easiest way.
So yeah, that works. What I was thinking was equivalent. You're going to use the fact that the middle marks the 50% on each side. So if I know 200 or more, so the middle and this tail is 76% about. So Well, from the middle to the edge would be 50. So if I take the difference between the 76.2 and the 50, I'll get half of the middle region, and you could double that for the whole region. Will subtracted.
I did Will's way, so
Will subtracted the 0.762, all this to the right, from 1, and he got this tail. And then he subtracted from the 762 that tail, because this tail is equivalent to that tail, and that left him just the middle. Does that make sense? So there was a couple different ways you could do it.
So how do I write that down so not to do it on the test?
no, you just gotta learn.
There's no way
Just
I'm
read the
gonna
question a
remember
couple
that.
times.
Just use the symmetry of the curve.
Okay.
You look at it,
Yeah, I'm not
you divide one
understanding this.
side,
I
and
need
then
a
you
better,
double, you get the other side.
All right, let me try this.
Like, I'm not grasping this.
Grasp this then.
That's how we pull off.
All right, that was terrible.
Why?
Okay.
So, I guess I get out.
All right,
I don't want to.
201, 762,
I don't know. Mine's not.
so you subtract
What
1
name does this mean? It's not
minus
gonna,
0.762, and that gets this right here.
it's not gonna hurt you guys.
And that's the same on this side.
It's not gonna hurt you. We're drawing ourselves a visual.
all right, you've got 0.762 right here. Does that make sense?
Yes.
And then you've got,
Yeah.
Yep.
you've got 50% here. Is that okay?
Yep.
So the difference will be half of the range. Right? So 0.262 is here,
Mhm.
right? Times 2 is that whole middle range. So what is that? 524?
What did I do there? That's the same thing you did. But then I just multiplied it by 2, then I divided that by 1. Or multiplied it by
Is that the problem? No.
Subtracted 0.762. 1, got it.
Mhm.
So looking back at that,
No.
200 and above was 76%. If you cut off 50%, that only will leave you from here to the middle. And if I double that, then I have this range. Is that better? All right, 5.
Oh, this is some trouble.
Wait a second.
Wait a minute.
It is a duplicate of 2. So what I do is I copy and paste and then I edit them, and then sometimes I forget to edit them, and then so 5 is a duplicate. 6.
One minute.
I heard you mean too.
Where's my name film? Your cap.
This one's tough.
Wait a minute.
So I'll
Hold up.
Wait a minute.
So if I'm ready for the house, okay.
Well, what do you get, huh? Wait, what, I know what I'm talking about. I didn't get my hand.
You know what, that's why it's the real surprise, because this month is before your birthday.
Well, no, not yet.
If it's half, like, if you go from 190 over, is that 0.5? Always?
Yeah, that marks the middle.
Yes.
Dang. That's good.
I know this is hard to believe, but I didn't get much of that.
Actually, I think you did. Is it 0.65?
I don't know. What'd you do?
Well, you see, Will can explain it because Will's really good.
Well,
Well, it took
make
me
on the
the
first
same
grade.
grade.
Oh, okay. Thank you. So I added 0.207.
That's right.
Then I added 0.071. But because it's 2.071.
Oh, it's symmetrical.
Because it's symmetrical, it's on the other side. So
Yeah.
I'll multiply that by 2.
Yeah, good,
And
good.
then minus that by 1.
0.65.
Very
0.6
good,
by 1
very
is
good.
exactly what I got.
Yeah.
I got negative points.
Well, he,
Well,
What did you
that's
guys
it.
do? You guys subtract 1 minus thing.
yeah,
Oh.
You do 0.207 minus 1.
yeah. So the whole curve has 1. The area under the curve is 1. If you subtract the two wings, they have the same size. You're subtracting the 0.071 twice. And then if you subtract the orange bit, which is the 0.207, all that's left is the yellow. So that would be,
Get that for you.
Just a minute, I'm gonna use your slide.
So the green and the red are the same.
Good.
yeah, the green and red are the same.
Wow.
Yeah.
So,
those are
how,
both
so your answer is
0.071. Add those
0.71
together.
minus 1 twice.
0.07.
No, it's, you have the whole thing as 1, right?
Yeah.
Add
It's 2.071.
2.07.
Because that's both sides. I multiply that by 2.
Well,
And that's your answer?
I added some
And
more.
I added it with point.
So that's your.
Oh.
Then you subtract it by 1.
so you know,
Mine's weaker. You go to the- oh, mine's weaker.
0.65.
I'm not the best person in the world.
Yeah.
Remember that?
you have the 0.071, was that right?
Yes.
And then you have it there too. You have, what was that one?
Easy fun. Pardon? You're a can.
I forget what that was. 0.207. So if I just do 1 minus the 0.207, minus the 0.071, and minus 0.071 again because it's over here as well, then all that I got left is what's in here.
And they look the same.
Because they all look the same, Greg.
Does that make sense?
Does it make sense? No. Does it? Yes. Oh, wait, what?
You know, all these regions, A, B, C, and D, they all add up to 1, right? So that means C
Which one?
must be 1 minus A minus B minus D.
Andrew, you're a can.
I finished.
Wow.
So A was 0.071, D was 0.071, and B was 0.207.
What?
Yeah, 0.207.
Win.
Is that okay?
On here.
All right.
Next one should be.
Next one's, I think this next one gets tricky.
0.1. This one's tricky?
I think so.
It's not.
No?
Well, Andrew doesn't think it's tricky.
I made,
7?
I don't remember.
The next one's probably tricky.
7 is, I thought that was a tricky one.
0.1354.
Well, let's people read it and then we'll see how you did it.
Which side has symmetry?
Two corners always.
Yeah, what are the corners?
That's the only one. See, it says 1900. The yellow side's at 1900. One more. So there's 2 of the points you choose.
Yeah, I guess that isn't that tricky, is it?
Yeah.
I think I was trying to make it tricky and then I just didn't succeed.
Oh, yeah.
Oh, I did not.
You get 0.13.
1354. 0.1354.
You got the same?
Yeah, I'm having problems like knowing which one is the symmetry. Cause I know.
Well, obviously the yellow and the orange are at the same size.
No, I know, but you cannot just tell what the number is. You can't.
The mean is,
Oh.
the mean is 1,500, right?
So.
Yep.
they gave you-
So how far-
This one.
From 1,500 is 1,900.
This one and this.
400.
And this.
So
one
how
the same
far
size.
is 1,100 from 1,500?
400.
So there's the same distance from the middle.
Yes. So how do you know that's 0.0228?
That's always.
Because I said so.
Because he said so, Bree.
I'm trying to drop.
1,900 or more is one.
I have to tell you.
I can't really tell you.
Yeah, I've seen.
So the sides are always gonna be symmetrical.
Pretty much.
Well, Well, if the mark is the same distance from the middle, just on the other side, then it cuts off the same size tail.
You can just look.
The curve is symmetrical. The yellow's kind of hard to see.
Oh, just line over pretty much.
All right, let me show you guys some, actually, let me see if,
Oh, it's so windy though.
heat from the sun is
It's a 4.
dissipating across the globe.
I'm not even near that.
Boom. That's not what I want to do. Get your calculators.
You gave us the. I'm doing one.
You guys ready?
Wait.
What are we doing? It's for 8.
Why am I playing?
Oh, this is Phasmophobia?
Is this for 8?
It will be eventually, but I'm just showing you how to do stuff on the
Well,
calculator.
Binomial C yet. Well, you put commas, so I just wanted.
Separate.
That's awesome.
Mario.
Yeah. Mario.
Who just said, oh my
Your
god.
generation is the list.
In the second key,
I
and
swear to
the
God, I do it
bars
all
key
the
is
time.
distributions. The second one in the list is normal CDF. You can either scroll down to it or simply hit the
Wait, what's this on? You're a cat. Why'd I do that?
Second list?
key
Oh,
for tips.
It's another distribution.
We started. Never mind.
This is another distribution. It will be in with binomial PDF and binomial CDF. One thing about these continuous distributions, like the normal curve, you're never going to, you never want to know what's the probability of getting exactly some number. Like these probabilities are like really small. It only makes sense to get like an area, like a region. So we're never going to use the normal PDF. We're going to use the normal CDF for the cumulative. We want to give it a range and get the value under the curve for that range. This guy is going to show you how to use a calculator to calculate probabilities given a range on a normal curve. All right?
CDF. All right, here's how you get to normal CDF. Hit the second key, and above the bars key is distributions. The second one in the list is normal CDF. You can either scroll down to it or simply hit the number 2. Now, I have the wizards turned off because I want this to be applicable also to people that have TI-83. The first thing I'm going to do is I'm going to calculate the area under a curve using z-scores, okay? I want to figure out the probability of a z-score being less than.
Okay. So for z-scores, I'm going to explain that in a little bit. But so when he's talking about those ones, his normal distribution has a mean of 0. So it's going to be centered on 0. So half of it's going to be in the negative numbers, half of it's going to be in the positive numbers. And the standard distribution for his curve that he's using is 1. So 1 represents the standard deviation.
Where did you find that again? The one?
Distributions, so you hit second var.
The one left it clear.
One under the arrows.
Oh.
Oh, is this what I was reading?
Then you go to distributions, normal CDF.
Which
if you have a newer calculator, it's gonna give you a menu to fill out, like what's your mean, what's your standard deviation. He's turned off the wizards, he said. So,
The wizard,
yeah,
like,
Green wizard.
-1, probability less than -1. So here's how we do that. First, I start with a lower bound. So because I want to test the probability of being less than -1, I'm going to choose an absolutely ridiculously large negative number,
Ridiculous.
like -9,999,
That's redundant.
comma. The
Should
next
get
one is the upper
0.21.
bound, so this is the z-score that I want. So this is the region that it's going to test for the area, comma. The next value should be the mean. Well, where everything is standardized, the mean is always 0, because everything is now unitless
Where'd they get
with
that 9
standard
number?
scores. Comma, the standard deviation is always 1, when everything is standardized.
Why does it look like that?
And parentheses,
yeah, so he shut off his wizard, so
the wizard,
How do I-
bring me the wizard.
Like,
So the first number goes,
999.
what's your first thing to ask?
Lower.
Excuse, what's that?
Lower. He said it
So
as he
they
went,
want the
but
lower
upward.
bound. So for this curve, listen up, you guys. When you put in the lower bound, if you see how he has shaded all the way to the left up to -1. So he wants to go to negative infinity on his curve. Your calculator might be able to have an infinity. I think some of them do. But if not, you just need to put in a number far to the left of the mean. You can put in -9 and you'll probably get the same answer because this is a very tight distribution. You could probably put in -5 and probably get the same answer. But to be safe, he's putting in -9999. This is as far to the left as he cares to go. A lot of people you'll see put in -1E99. That might be the biggest number that the calculator can take. So to be honest, the curve gets so small once you get past 4 on this thing, -4, that none of those, that's going to make no contribution pretty much. So he just put -9999 for the lower and -1 for the upper bound. The mean for him was 0 and the standard deviation was 1. He should get like 21%.
but what I'm looking at here, this is the probability.
No, I thought it was going to
Value would be less than the z-score of -1. So that's about 15.87%.
Is that right?
Okay, now, let's go ahead and run a normal CDF with values that are not standardized. So let's say, for example, that I spend on average $200 for Christmas with a standard deviation of $60. What's the probability I spend more than 300? Let's consider that as an option. Okay, here's how you do it. Second, distribution. Again, choose number 2 in the list. Now, my lower bound is I want to test the probability of greater than 300. So my lower bound in this case is the number 300, comma. Now I choose a ridiculously large number, like 9,999. The mean that I spend, the average I spend on Christmas would be $200 with a standard deviation of $60. Close the parentheses, let's hit enter. So the probability that I spend more than $300 on Christmas, if my mean is $200 with a standard deviation of $60, is about 4.78%. That's how you do normal CDF, both with standardized scores and without standardized scores. God bless you, wherever you are today.
Was that? Anyway, is that okay?
oh yeah.
Yeah.
All right. There's another one. So like what that gave you was if you take a range of values, it can tell you the area under the curve, which is equivalent to the probability of getting a value in that range. You can go the other way. If you want to know, if you know the probability and you want to know where the cutoff is, there's the inverse normal. It goes the other way. So let me show you that one too.
I was scratching YouTube for math help. That tutorguy.com has videos.
Look at that curve with the face.
I love that tutor guy.
All time, but
Since we know the gestation period is normally distributed, let's stamp a normal distribution. Now, the mean is 200, so
Nice
that's right
stamp.
here in the middle. And since the standard deviation is 3.5, we know right here is 203.5. So 204 must be about right here. So the proportion we're interested in is this area. Now, the area under the entire density curve is 1. So just by eyeballing this, we know it's probably somewhere in the teens or maybe around 10%. Now, in this situation, we have the cutoff value, the 204, and we're trying to find the area. If you have the cutoff value and want to find the area, use the normal CDF function on the calculator.
The area is the probability.
To use it, press second vars. This is our distribution menu. Go to norm CDF, and it's going to say, what's your lower limit? In this case, it's 204. Next, it asks, what's your upper limit? We don't have an upper limit. We're going to go all the way to positive infinity, which we can't input into the calculator. So let's just type a bunch of 9s. For mean, we're going to put 200, and for standard deviation, 3.5. Now, when we press enter on paste, and then enter again, here's our area. So the proportion that lasts longer than 204 days is about 0.1265. For part B, we're going to stamp another normal distribution. In this situation, we have the area, the 10%, and we're trying to figure out what the cutoff value is. So we want to know what cuts off the lower 10% of hippo pregnancies. That's probably about here. So we know this number is 200. We're trying to figure out what this cutoff value is. So if you have area, and you're trying to figure out what the cutoff value is, use inverse norm on the calculator. To access it, press second vars. This is our distribution menu again. And we'll go down to inverse norm, and it says what area you have. Now our area is 10%. The area it's referring to is how much area is to the left of the cutoff value you want. And in our case, 10% is to the left of this unknown cutoff value. Now we'll put the mean and the standard deviation. And there we go. The cutoff value is about 195.5. So again, if we have the cutoff value and want the area, use normal CDF. But if you have the area and you want the cutoff value, use inverse norm. So let's look at the next one.
All right. Is that good?
Where do you keep getting these 200 and 3.5?
You have to. He's given the mean and the standard deviation in the
Wait, how do
problem.
you know if it's asking for like the cutoff value or like the?
You don't have the smallest.
If it tells you a probability, and it says, what number of days or what, how many cars or whatever, if they want a number rather than a percentage, like a probability, then they want the cutoff value. They want you to use inverse normal. If the thing is asking for a probability, like a percentage, then you're going to want to use normal CDF. All right, so this one, okay, given a mean of 50 and a standard deviation of 9, there's a curve. What value corresponds to the 75th percentile? What does that mean, the 75th percentile?
Like more than 75 or less than 75?
What was that?
Does it mean it's over 75 or less?
You're
75th percentile, you're like better than 75.
yes, yeah. So 75% is at this level or below, right?
So it means you're really good. Will.
So you would be above 75%, right?
You're asking for like,
0.002737.
Did you do the inverse? What'd you do?
you put 0.75 in there or you just said?
All right, so
What's that U?
when they said the 75th percentile, that means we want a cutoff value that's gonna have 0.75 as the area to the left. Does that make sense?
Yeah.
So let's use the inverse normal.
So it's 56.7.
That sounds better.
You put this less in.
With inverse 0.7550 and I.
I didn't do this. I'm lost.
Did you do the inverse normal?
Well, like, what do I put in there?
This one?
It asks for the area, right?
What's the inverse one?
Yeah.
The area is gonna be 0.75 because you want 75% to the left.
But like, where do I?
For area, 0.75.
Oh, it's 1694.
Does yours have a menu?
0.556.
Put 0.75.
And then the mean is 50.
Wait, do we have an upper and a lower?
No. We just want to know the cutoff value. So we're using the inverse normal, not the normal CDF.
Inverse.
Okay, I did that then.
Yeah. So if you have a percentage or a probability,
You just have a picture of this.
you're going to use the normal, inverse normal,
So the area would be,
0.75.
okay,
The mean is 50. The standard deviation is 9.
got like 56.
Is that good? We'll come back to the z-score thing. Okay, what is the probability of a value of less than 112 if the average in the population is 200 and there's a standard deviation of 21? What'd you get?
This is just a normal.
Are we at 9?
Yeah, this is a normal CDF. We're at doing 10. We're going to skip the z-scores for a minute before I explain it.
0.0001440.
Sure, yeah,
That's right.
I think so, because
That's right.
112 is so far over here that there's like
What
nothing.
did you put first?
There's almost no chance.
You put it in.
Yeah, that's the first number.
Like, go ahead and do it again, Will, but put in 0 instead of negative 9999. Honestly, you could just put in 100. I don't think it's going to change your answer. What's that?
So is this
Standard
normal
deviation sign is
CDF?
this U thing.
No,
It's the
that's
sigma.
Sigma. Circle is any standard.
Did you say sigma?
Yes, lowercase sigma.
When I put zero, oh, it's come out the same stuff.
Yeah, right? Because that stuff in the tail is so minuscule, it doesn't even register.
Oh, I did not get that. So this is.
I got it. It is the same. It is the same.
Excuse me?
This is normal CDF?
Yeah,
What were we supposed to get?
very small number.
I need to put
What did you get?
1.3927 blah 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 times e to the negative 10.
So it's very small.
No, because
Yeah,
it's the lower bound.
but I didn't get like 0.04 or whatever.
You have a 0.
Oh,
Like a zero there.
If it wants to know what's less than, you
Yeah,
need to
so
know.
that's for the lower bound.
Is that good? You should get like very low probably.
Put them together.
These all coming together.
All right, what is the probability of a value more than 230 if the average is 200 and the standard deviation is 21?
Yeah.
0.076?
Yeah.
Is that what everybody else gets?
5, 6, 3, 7, 7.
It will make it fine to do it.
You guys are in agreement with Will? Good. I said they're in agreement with Will? Good.
Oh, my God.
More than 2, 3.
Inverse.
I don't know when to put like the 9 of them.
Because when it's
Mine's too hard.
You don't know what's above that,
Is
so
it?
230.
No.
Why don't you switch to something easier then?
What?
Why don't you switch to something easier then?
That's why it's too easy. I need a challenge. I'm using probability on this. I'm using this on this. I have good odds of this being a bomb, so I'm gonna put a flag over it. Bam.
Hey, can you spell your last name?
This one looks
It like
good.
looks small.
Good.
Oh, wait,
Oh, you know, just NEUB. AUER.
What? So, what number did we just do?
That's 11.
AU.
ER.
11 and 12 is a duplicate.
Oh.
I like looked wrong. Wait, okay.
Oh, trust me, it's wrong.
12 is another duplicate.
So,
There's a few duplicates.
Which one's the one we just did?
The last one.
11 or 12, they're both the same.
Not the same.
I duplicated it and I never edited it.
27, yeah,
Oh, yeah,
it is
no,
the same.
can you just leave it up there for a minute?
No.
Wait, I got it.
So, in your, like, the lower is what? 0?
230.
That was 0, no, that was 230.
How do you know what that is?
The next one's like.
You don't.
Because read the question. It says, what's the probability of a value of more than 230? So you're going to have a cutoff at 230 and
You
everything.
don't know what's above 230.
And then upper.
So that's the 999.
Honestly, if you put in like 300, it'll probably give you the same answer.
It's not the same satisfaction as you get spam 999.
That's true. That's
So
true.
you did the lower end 0. How's that do?
Do you, I guys probably don't remember Herman
What's for
Cain's
lunch today?
presidential campaign. He had the 999 tax plan.
I don't-
999. He used to work for like a pizza company. And everybody said that his 999 deal for taxes sounded like a pizza deal, like a.
Dang.
You see it?
He was the guy who was like, he's like, he complained about how big some of the bills are that they pass. He's like, if I'm president, there'll only be small bills.
How many have you like equally?
It was funny.
Equity. Nah, wait for what? Oh, no, it's equity.
On the back.
All right, 13. What is the probability of a value between 180 and 220 if the average is 200 and the standard deviation is 21?
Is this an inverse thing?
No.
We just put lower and then the upper. This is number.
180
That's
and
right.
220?
That's right. Yeah.
I know who it is, but I don't like the number that you get. Oh, then yeah, that's probably. Have you done me yet?
I get it.
I wanna know.
Easy?
First thing in this whole year.
Wait, this is the first thing that you get? Yeah, boy. Good job.
That last one, I grinded his YouTube video.
Looking at deck of cards.
I ate, slept,
No,
and drank. with that.
So I can go CEO first. Or you're good.
All right, how about this one?
Modern cards.
What's this an inverse?
Yes.
Just doing yourself.
What value has 60% of the population above it? So what are you going to have to put in for the area for the,
60.60.
no,
0.40.
0.40?
Why is it 0.4?
Because the area for the calculator wants to the left of it, below it. And this, they want 60% above.
That's not fair.
But where do you get that number?
That's the difference. 60 and 40 make 100.
Oh.
Well, you gotta show me this one.
So that's the area?
The area will be 40
Why is it-
below to have 60 above.
So it'd be 0.40.
Yeah.
How you gotta put
78.
You did not do it.
Probably, I don't know.
What value has population?
1560.
Above 60%.
So 1560, and then you put below that for like,
1560.
you put 321.
In the order, yes.
Why can't I do like?
Is that 1478?
Go for a nice little snack.
Is that right? Francisco?
I don't know. I have to check it. I need a calculator for these. I can't just like.
You think about it. Thinks about it, computer.
Yeah. I'm working on it. Open and so. Let's see if I can find the
So
calculator.
why did you put 4 there?
Because if you want 60% above, that means you're going to have 40% below.
Yeah.
and the calculator wants to know that what number is below.
Huh? Mika?
You might.
14, point 30,
Step brother.
Step bro.
1560, and then 321.
Where's my
What?
Here we go.
Will?
Will, good job. That was good.
Oh, here I've got the distribution calculators. I've even made things like this before, but they've got a nice one here. Normal distribution. You can put in a mean value. Oh, this is limited.
We're gonna give me a.
You can put in a standard deviation.
You want one?
Yeah.
That'd be good at trying that one.
What is it?
Actually, only in Taiwan.
Good for you that has any numbers.
Yeah, only in
And
Taiwan.
not letters.
Do they speak English there too? You know,
English.
I'll get you guys a better one of this.
Um,
But this also has like a binomial distribution, and you can kind of see it. So let's say we have like 50 trials, chance of success is 30%,
I think seeing it's what messed me up.
maybe 26 trials.
I am starving to every.
oh, you're hungry too?
So this is nice. You can get a binomial distribution or the normal distribution, and then you can calculate probabilities that way.
Me neither. I mean, I tell you what, this is. We got
I left it there.
We gotta stop lifting.
just had curl there. We didn't know.
I'm gonna look
Pretty sure it's like red.
What were we supposed to do?
Today.
I don't know.
1478.67.
Do you?
Well, it's not like a.
Every day.
I can tell.
Yeah.
You're so big, so strong.
I don't remember.
George, do you see him? See how strong Andrew is? Look at him. See his biceps? Yeah, you're bigger.
Why don't you just click on that? It's locked. It's this one right
Yeah,
here.
it has.
Well.
Oh.
What's the population about it?
Do you have my phone?
I don't understand what that's about.
Values.
She was 0.4.
Okay. I think I know what it is.
Look at me.
So do you remember when we reversed? So
Oh, that's-
that one guy? You have my, the other shield.
What?
Yeah, wait, why did we put like four in?
What?
Because if you have 60% above, that means you have 40% below. And the calculator wants to know what percent you have below.
Oh.
So just be watchful of that.
You're so creepy.
Probably just put it in the back.
Hair one
We're in the pocket.
All right.
Only the good stuff.
Okay, there's something called a z-score. So we're going to combine this score with the normal distributions at some point.
What range of numbers centered around?
Oh, don't worry about that. Don't worry about
Sorry
that.
about that.
So I'm just going to explain what a z-score is.
Where is it?
Let's say you have some distribution. The mean we'll say is, what do you want for a mean value? IQ is 100 with a standard deviation of 15. Usually.
Andrew is 200.
All right, so 200, right?
Your what? Your IQ. 200.
If someone doesn't get to
Is that good?
so long.
I think average is like.
100.
Can you take an IQ test?
Not if it's not real if it's not administered by a psychologist.
Yeah, Andrew's 100.
Do an online one.
I know who took it.
I always get like genius, like
Do
yeah, I get like 138, 132. It's like
That means you have a very high IQ.
Well, they're like, yeah, they're like, you're so smart. Click here to buy the full report.
Well,
Like,
doesn't IQ not really have anything to do with like
It's
being
really
like book
impossible.
smart or something? Like it's
no,
Albert Einstein was like,
it has to do with aptitude. So like, it shouldn't be intelligence. It should be called aptitude, which means how good at you, basically at school like stuff. So when you're in school, your IQ's higher. When you leave school, it tends to drop.
I knew you had it, man.
Um,
He's like, it's only a 6 1.
it's not like a measure of what you're
Yeah,
capable of,
seriously,
but, you know, like
it's fine, it's fine.
ultimately.
so
But does correlate to income over life and things like that. So usually higher IQs usually get paid more. Okay, so this is called a Z-score. You just take the value, subtract the mean.
a mean.
Yeah, it's 100. So find, and then divide by the standard deviation. So this basically tells you how many standard deviations you are from the middle.
So it's 200.
What's X?
So 100 over.
The value that you're looking at.
Well, what is it? 100 over 15.
And what's the thing down there is the
Oh, it's
deviation.
supposed to know.
What's that?
The thing down there is the deviation. The bottom number.
Yeah, the standard deviation. So this is 10 and 10, right? This is 5 and 3, like 2. So that's 20 divided by 3. That's like 6.7 or something like that, right?
We're close. Wait, so Z is equal to X minus mean over.
Yeah.
standard deviation.
This is the z-score for a particular number. If you take that number, subtract the mean. So if it's bigger than the mean, you'll get a positive number. If it's less than the mean, you'll get a negative number. This gives you sort of the distance from the mean. And then divide that by standard deviation to count basically how many standard deviations you are from the middle, positive or negative.
So what do we put in for X? Just
Whichever value. If I'm looking at 200, the z-score for that would be, what would we say, 6 something? If I could look at what's the standard deviation of 105.
What if it could do 25%?
Are you looking at one of the questions?
Yeah.
Um,
The one we skipped.
yeah.
Wouldn't that be over 20, not 10? 20 over 3?
What?
Because you took out a 5.
What are you talking about?
Yeah, 5 and a 3. And I left a 2, right? So it's 20 over
Oh, I
3.
didn't see the 2 above. I thought it was 10 over 3. I'm like,
Yeah, it's kind of small there at the corner.
I was like,
The Z.
So a type of question that you'll get for that sort of thing is like, okay, in the running competition, I don't know, what's an average like run time for?
7 minutes
That's okay.
and 30 seconds.
Our run time?
For what?
Huh?
For what?
A mile.
A mile?
For half a mile.
You're high.
That's mine.
That is yours?
7 seconds.
You're not that
7
fast.
minutes.
You're not that
I was
fast.
thinking 3 minutes for me.
Holy cow.
No, I'm kidding.
So what's, how many seconds?
I'm driving.
You know what?
32.
This is Mexican.
So what is that? About 450 seconds altogether?
Who knows those stress?
What'd you say?
Jordy said 7 minutes? Yeah.
32 seconds.
That's a mile?
420 seconds. Your mile.
She said 6 minutes and 32 seconds?
7 minutes.
7 minutes.
Or 7 minutes? Yeah, 7 minutes and
7 minutes.
Definitely not.
10,200 seconds.
in 32 seconds, did you say?
Yeah.
Wait,
Yeah, so 60 times 7 is 420 seconds.
So 450.
Then add the 32 seconds, 452. I guess I need a
Yep.
2 in here.
must be high. Hang on.
All right, so let's say your time for a mile is 452. And let's say, and then, so like a common question is, Okay, the average for girls, there's some mean value. So like,
The average for girls is 5. Girls is
and the average for boys, well, actually, I think they're quicker, aren't they?
Boys are slower.
Are they?
Yeah.
I don't think so.
Oh!
Boys are slow. Okay.
Maybe.
maybe in a different way.
Okay, so the idea here is that you're a value that might be long for boys, might be past the average, could be below the average for girls, right?
Below average.
So what you can use a z-score for, instead of your actual time, is if you took your value, 452, and let's say the average for girls was 500,
Oh.
That's 700.
and let's say the standard deviation is, I don't know, 20.
Yep. Yep. Yep.
It probably is bigger than 20.
Yep.
Yeah, that'll. So here I get what, negative 48. So divide by the 2, that's usually negative 24. Divide by the 10, it's negative 2.4,
Oh.
right?
Yeah.
So that means you're 2.4 standard deviations under the average, right? Whereas let's say for boys, 452, maybe the average for the boys is 440 with a standard deviation of 20. So they would be a positive number, 12 over 20 for z-score. What is that, 3/5? I don't know what that is as a fraction. 0.2 times 3, it's a 0.6. So the same time, but depending on which group you're comparing yourself to, you're either less than 1 standard deviation past the average, or you're nearly 2.5 standard deviations under the average, depending on the group. So z-scores can kind of tell you how you did relative to the average. Does that make sense? Now, so here's the formula for the z-score again. You take the value minus the mean divided by the standard deviation. If you knew the z-score and you wanted the value would be the mean plus the z-score times the standard deviation. Does that make sense?
Yeah.
So just take the middle, take the number of standard deviations you are from the middle, multiply by how big the standard deviation is, and move that far from the middle, plus or minus, depending on the z-score sign, and that'll give you your value. So what number were you looking at, Will?
No. Not anymore.
No? Okay, this one says what number has a z-score of 1.25? So that means to find the value, you would take the mean, you would add 1.25 times the standard deviation. So 1.25 times 321, add that to the mean. That's all you got to do for that one.
What number is that, 18?
Yeah.
So you do
1.25 times 321
Yeah.
plus 1,560.
Add that, yeah. So 1.25 tells you how many standard deviations you are from the middle. That's what the z-score means. So I'm 1.25 standard deviations above. So if I take 1.25 times the standard deviation, that tells me how much past 1560 I am.
So 1961.25.
Yeah, that sounds good.
55 to 1.
Oh wait, no, it should. Yeah, that sounds right. That's close, right?
That's about it for today.
Yeah, I'd say it's about ready to call it a day.
It's 50 something.
Easy?
I know it's a little bit.
Yeah, the count.
Easy.
The count is- and you won't-
Oh.